Welcome to a deep dive into the Indian Space Research Organization, ISRO for most people.
Yeah.
We're going to be using excerpts from their Wikipedia page.
Okay.
And it is fascinating. Let me tell you, there are twists and turns you might not expect.
Yeah, what's really cool is how ISRO went from, sort of humble beginnings and became this huge global player in space. It's really a story of ambition and innovation.
Okay, let's start with the humble beginnings. Where did India first kind of get involved in space research?
Well, this might surprise you, but it all started back in the 1920s. Long before the space race even started, there were scientists like S.K. Mitra doing some pretty groundbreaking experiments with radio waves to understand the ionosphere.
Wow, the 1920s. So they were getting started really early on.
Yeah.
But when did they actually start thinking about a dedicated space program?
Well, that comes a little bit later, mid-20th century, and you have these visionaries like Vikram Sarabhai and Homi Bhabha,
Yeah.
and they really recognized the potential of space technology and pushed for India to have its own program.
So they saw it as more than just science.
Exactly. Sarabhai especially understood that space tech could solve problems here on Earth. Things like using satellites for communication, education, weather forecasting, you name it, harnessing space to help people.
That's pretty forward thinking for that time.
Yeah.
So we've got these pioneers, but I'm guessing Sputnik in 1957 really kicked things into high gear.
Oh, absolutely. Sputnik's launch by the Soviet Union, that was a huge deal for everybody. It basically started the space race. And for India, it was a sign that space wasn't just a dream anymore. It was actually happening.
Right, other countries were doing it.
Exactly. It was a wake-up call, and it really energized India's ambitions. In 1962, they formed INCOSPAR, the Indian National Committee for Space Research.
INCOSPAR.
Yep. That was basically the precursor to ISRO, a way to get organized and really focus on space research.
So they were getting serious.
And here's a fun fact.
Yeah.
They even brought in officers from the Indian ordnance factories to help out. They had expertise in things like propellants and materials, thinking outside the box and finding the right people for the job.
Yeah, so INCOSPAR, is there the foundations laid? When does it officially become ISRO?
That happened in 1969. And to really show their commitment, the government created the Department of Space in 1972, putting ISRO right under it.
So they were putting resources behind it.
Absolutely. And just a few years later, in 1975, India launched its first satellite, Aryabhata.
Aryabhata. That must have been a huge moment.
It was monumental. And get this, it was a collaboration with the Soviet Interkosmos program.
Interesting.
They provided the launch vehicle, but the satellite itself was designed and built in India.
So they were learning from others, but also doing things themselves.
Exactly. That's the thing. They were collaborating, but always striving for self-reliance. And at the same time, they were developing their own launch vehicles, SLV-3 and ASLV early rockets, but essential steps towards independence in space.
Okay, so satellite launch vehicles. It sounds like smooth sailing from here.
Not quite. Developing this kind of technology is incredibly complex, and ISRO had its fair share of setbacks in those early years.
Makes sense. I mean, it is rocket science.
Literally. But here's the thing about ISRO, they never let setbacks stop them. They analyzed what went wrong, learned from it, and came back even stronger.
They kept going.
That resilience, that's what defines their journey, and throughout the 1980s, they made some serious progress. They expanded their satellite systems with INSAT and IRS, which really laid the groundwork for India's role in communication and Earth observation.
Hold on. INSAT and IRS. Can you explain those a bit more? What did those systems do?
Sure. So INSAT, that's all about communication. Think television broadcasting, telephony weather forecasting, disaster management, pretty much everything.
Wow, that's a lot.
Right. And then you have IRS, the Indian Remote Sensing Satellite System. That one's focused on observing Earth from space. Things like monitoring crops, managing natural resources, tracking deforestation, you name it.
So these systems were pretty crucial for India.
Absolutely. They showed how space tech could be used to make a real difference in people's lives.
Okay, so they're doing well with satellites, learning from their rocket launches. It seems like things are moving in the right direction. But then I came across this thing about cryogenic engine technology and how the U.S. placed sanctions on India.
Right.
That sounds like a big problem.
Yeah, that's where things get a bit tricky. It's where space exploration starts to mix with geopolitics.
Okay, so what's the deal with cryogenic engines? Why Were they important for ISRO, and why did the U.S. want to block them?
Okay, so you have to understand that regular rocket engines, they're good for getting things into space, but not so efficient with heavier payloads or higher orbits.
So limitations on what they could launch.
Exactly. Cryogenic engines, they use supercooled fuels like liquid hydrogen and liquid oxygen. This makes them way more efficient so you can carry heavier satellites or travel further into space, like to geostationary orbit where communication satellites stay in one place above Earth.
Gotcha. So these engines were key for SRO.
They were essential for taking things to the next level. But the U.S. saw this tech as very sensitive. They didn't want India to have it. So they put sanctions in place to stop India from getting cryogenic engines from Russia.
It's more than just science then. It's all connected to politics and global stuff.
Exactly. It was a setback for sure. But, as we'll see, it was also a turning point. It pushed India to become even more self-reliant.
All right, this is fascinating, but we're going to have to leave it there for now.
Okay.
We'll pick this up in part 2 where we dive into the PSLV. The Kargil War's surprising connection to satellite navigation and some seriously ambitious missions to the Moon and Mars. Stay tuned.
All right, sounds good.
All right, so we're back, picking up where we left off with ISRO facing those sanctions on cryogenic engine technology. That was a tough spot for them.
Yeah, a defining moment for sure. But instead of giving up, they decided to do something pretty amazing.
What'd they do?
They basically said, we'll build it ourselves. They doubled down on their efforts to develop their own cryogenic engines.
Wow, that's bold. But how do you even start with something that complex? Especially when you're basically on your own.
It was a huge undertaking. It took years of research development testing. They had to build the facilities, train scientists and engineers, get the materials. It was a real test.
So while they're working on that, what else is happening? Are they still launching satellites and making progress in other areas?
Oh yeah, definitely. They didn't put all their focus on one thing. In the early 1990s, they introduced a new launch vehicle, the PSLV, or Polar Satellite Launch Vehicle, and that changed everything.
Okay, I've heard of the PSLV. It's like their most famous rocket, right?
It is, and for good reason. It became their workhorse, designed specifically for launching satellites into polar orbits, which are really important for Earth observation and science missions.
So it's not just about getting to space. It's about getting to specific orbits for different purposes.
Exactly. And the PSLV was perfect for that. It was reliable, cost-effective, and could consistently deliver satellites right where they needed to go. It gained a reputation for being precise and high-performing.
So they have this reliable launch vehicle that can carry satellites into polar orbit. What did that mean for their space program overall?
It was a big deal. It meant they could launch way more satellites for different applications, communication, navigation, remote sensing research. It really put them on the map as a major player.
Yeah, it makes sense.
Yeah.
So ISRO has the PSLV. They're working on that cryogenic engine for the GSLV, the one for those heavier payloads in geostationary orbit.
Exactly. And that's where the cryogenic engine is crucial.
Right, because to put those communication satellites up there where they stay over the same spot on Earth, you need a powerful engine.
You got it. And ISRO was determined to figure it out despite those sanctions. It took a long time, but they eventually did it.
Wow, talk about perseverance. They hit a roadblock, and instead of giving up, they spend years developing their own technology. That's amazing.
It really shows their commitment to self-reliance. They didn't want to depend on other countries for something so important.
So they're making progress on multiple fronts. Then the Kargil War happens in 1999. How does that connect to ISRO?
That's where things get really interesting. During the war with Pakistan, India realized they needed accurate location data for their military operations.
Like GPS.
Exactly. But here's the thing. The U.S., who controlled GPS at the time, they wouldn't give it to India.
Seriously? They denied them access to GPS during a war. That's pretty harsh.
It was a wake-up call for India. They learned the hard way that relying on others for crucial technology, especially during a conflict, is a big risk.
So they're in the middle of a war.
Yeah.
They need this technology, and they're told no. What do?
They had to figure something out. They realized they couldn't be dependent on anyone else. They needed their own system. And that's how NavIC was born.
NavIC, India's own satellite navigation system. That's incredible. How a challenge like that can lead to such innovation.
Yeah, it shows how geopolitics and technology are often intertwined. And ISRO's determination to be self-reliant really pushed them forward.
They overcome the engine challenge. They developed their own navigation system. It feels like ISRO is really hitting its stride now going into the 21st century with a lot of momentum.
Absolutely. And this is where their ambitions really take off. They set their sights on some pretty big goals. Lunar probes, a Mars mission, even plans for sending their own astronauts into space.
Yeah, okay, slow down. We need to unpack all of that because it's a lot to take in. Let's start with Chandrayaan-1, their first mission to the moon. Tell me everything.
All right, Chandrayaan-1 in 2008. This was historic. It wasn't just about going to the moon, it was about scientific discovery. They had instruments to study the lunar surface, its composition minerals, even looking for water ice.
So it was all about exploring and learning.
Exactly. And it was a success, too. Chandrayaan-1 made a major discovery. It found actual proof of water molecules on the moon.
Yeah, I remember that. It was big news. And it really put ISRO on the map.
It did, and it opened the door for more lunar missions like Chandrayaan-2, which tried to land a rover on the moon, and Chandrayaan-3, which successfully landed near the lunar South Pole.
So they kept building on what they learned.
Exactly. And then in 2013, they launched the Mars Orbiter mission, Mangalyaan.
Mangalyaan.
Yeah, this made India the first Asian nation to successfully reach Mars orbit, and they did it on their first try.
First try. That's
Oh.
amazing. It feels like with each mission they were proving themselves to the world.
They were, and they did all this while keeping costs low. Their Mars mission was much cheaper than similar missions from NASA or the European Space Agency.
So they're doing all these incredible things on a budget.
Yeah, they're really efficient and innovative. They're always looking for new ways to do things, whether it's building lighter spacecraft or finding clever solutions to problems.
Okay, so we've covered decades of progress and achievement. It's amazing.
Yeah.
But where do they go from here? What's next? So ISRO has done all these amazing things. Where do they go from here? What's next?
Well, that's what's exciting. They're not slowing down. They've got some really big plans for the future.
Like what? Moon bases, Mars colonies?
Maybe not that far yet. But remember their goal of sending Indian astronauts into space.
Right.
That's the Gaganyaan mission, and it's actually happening.
Wow. So they're really going to send humans into space. Sending robots is one thing, but people, and that's a whole other level.
It is. It's a massive challenge. They have to build a spacecraft that can carry people, train astronauts, make sure everything is safe. It shows how far ISRO has come.
What exactly will the Gaganyaan mission do?
The plan is to send 2 or 3 astronauts into low Earth orbit for about a week. They'll do experiments, make observations, and get experience in spaceflight.
So it's a first step towards bigger human spaceflight missions.
Exactly. It's about showing they can do it safely. And it opens the door for even more ambitious things later on.
Speaking of ambitious, I heard something about India building their own space station. Is that for real?
It is. It's still early stages, but they're serious about it. It's the next logical step after Gaganyaan, a permanent place to do research in space.
An Indian space station. It sounds like science fiction. How will it compare to something like the International Space Station?
It'll probably be smaller, at least at first. The goal is to make it modular so it can grow over time. It'll be a symbol of India's technology and their commitment to science.
So they're really thinking long term.
Yeah. And it'll be a place for international collaboration, too. Scientists and astronauts from all over working together.
That's amazing. To think that India could be a leader in space, bringing people together to explore the universe.
And it's not just about sending people to space. They're also doing great work in planetary science and astronomy. They have their own space observatory, AstroSat. It helps them study black holes, galaxies, all sorts of things.
So they're looking deep into space, trying to understand how it all works.
Exactly. AstroSat is a powerful tool. It allows Indian scientists to contribute to our knowledge of the cosmos. And then there's that discovery of bacteria in the stratosphere, the ones that might be from outer space.
Yeah, what was that all about?
It reminds us that space exploration is about more than just looking outward. It's also about understanding our own planet. These bacteria could tell us about the origins of life and the possibility of life on other planets.
It's incredible that we're still making those kinds of discoveries here on Earth.
And ISRO is right there pushing the boundaries. They're developing reusable rockets, new propulsion systems. They're always innovating.
They never stop.
And they do it all while keeping costs down. They've shown that space exploration doesn't have to be super expensive, which means more countries can participate.
So it's about making space accessible to everyone.
Exactly. And we can't forget about the practical applications of their work: communication navigation, Earth observation, but also things like disaster management, telemedicine education.
It's amazing how it all connects.
It's about using space to benefit humanity. And it's not just for India. They work with space agencies from around the world, sharing what they know, working together.
ISRO is a great example of what can happen when a country embraces science and technology. It's inspiring.
Their story is about big dreams, hard work, and amazing achievements. It shows that anything is possible.
Well said. And on that note, I think it's time to wrap up our deep dive into ISRO.
It's been a journey.
But it doesn't have to end here. There's so much more to learn about ISRO, their past, their present, their future. So keep exploring and keep asking questions. What role will India play in the future of space? Can their approach to space exploration inspire others? There's a lot to think about.
There is.
Until next time, keep looking up and keep wondering.